In this video, we'll prove the general statement for EMGM inequality using mathematical induction. So when n equal to 1, the conclusion apparently holds because you only have one term x1 on the left and another term x1 on the right. So they are naturally equal to each other. If n is equal to 2, we proved the claim before as well. So we must show that the arithmetic mean, the sum of x1 up to xn divided by n, is greater than or equal to the geometrical mean, nth root of the product from x1 to xn. Without loss of generality, we're going to rescale the xi's so that we make sure the product of them is always equal to 1. In which case, if all of them are equal to 1, then the proof is trivial, because if you sub in 1 to the left side, you would have 1 plus 1 up to the last one, which has n minus of them divided by n, will give 1 on the left side. Therefore, we're going to assume at least one of them is greater than 1, and the other one, and one of them is less than 1. So we're going to let the first term, x1, to be greater than 1, and the second term, x2, to be less than 1. By the inductive assumption we have, let's treat this product as one term for now. So x1 times x2 plus x3 up to x sub m. And note here we have n minus 1 many terms. This is going to be greater than or equal to n minus 1th root of the product, the first term, x1 times x2 times x3 times all the way to xn. And this, based on our assumption, is equal to 1 already. So we would have x1 times x2 plus x3 all the way to xn is greater than or equal to n minus 1. So all we did is to move this denominator n minus 1 to the right side. So this is what we assume to hold using induction. Now we need to show the final conclusion, which is x1 plus x2 all the way to xn is greater than or equal to n. And this would always follow if we have x1 plus x2 minus x1 times x2 plus 1 is non-negative. So why this term? Because if we move this 1 to the left side from the previous expression, then we would have x1 times x2 plus 1, and then plus x3 plus x4 all the way to x sub n is going to be greater than or equal to n based on our induction assumption. So we would be able to prove our final conclusion if this difference here is non-negative. And it turns out to be true because you can factorize the difference here as x1 minus 1 and 1 minus x2. Because we already assumed that x1 is positive and x2 is negative, so both terms are non-negative. Therefore, we can prove the claim in this way.